Hello everyone, welcome back to Mahasri for Electric Zone. In today's class, we are going to understand a very important concept in DC machines, and that is commutation. You might have heard this word before, but what exactly is commutation? Why is it needed? And what happens if it's not done properly? Let's explore everything in a very simple and clear way. What is commutation? Imagine a DC generator, where the coil keeps rotating between magnetic poles. Now, every time the coil rotates and crosses a brush, the direction of current in that coil has to reverse. This reversal of current, as the coil passes the brush axis, is called commutation. It happens in a fraction of a second, but it's super important. If commutation doesn't happen properly, we'll have problems like sparking at the brushes. So it's not just a concept, it's a real issue in machine performance. The basics. What actually happens? Let me explain with a simple example. We are looking at a two-pole lap-wound DC generator. In this, there are two parallel paths between the brushes. So the total armature current is divided equally. Each coil carries half the current. Say total armature current is 40A. Then each path has 20A. Now look at the brush touching the commutator segment. When a coil comes in contact with the brush, current starts flowing through that brush and commutator segment. But as the armature rotates, the brush shifts and touches the next segment. During that transition period, the coil is connected to both segments. It gets short-circuited by the brush. This short time, where the brush is connected to two segments, is called the commutation period. If current reversal is completed during this period, it's ideal commutation. If not, sparks fly. Ideal commutation. Explained simply. Let's take the case of ideal commutation. What does ideal mean? It means the current reverses completely and smoothly, with no sparking. Here's what we assume.